semiconductor. Now let's start. Okay, semiconductor. So 三种 conductor, insulator, semiconductor. Conductor 就是 metal, insulator 就是 non-metal, semiconductor 就是 semi-metal. So semi-metal 你可以看到在你的 periodic table 中间的那一 part. Okay, you have many semi-metals. Okay, the most two common one that you must be familiar here is the silicon and the germanium. Okay, so we have silicon. What is the electron arrangement of silicon? Si 284，两个 electron， 8个 1 2 5 6 7 8 and the outermost shell it has 4 1 2 3 4. So semi-metal 它的 valence electron 是有4个的 ，OK， 准4个 ，silicon 284 germanium 也是4个，它是2884 4 shells total. So the atom size is a bit bigger, but both of them they are semiconductor, semi-metals. Okay, now, so what is so unique about semiconductor? You see, semiconductor, right? They are used in many industry, like computer, phones, tablets, TVs, radios, everything, every devices, they use semiconductor. Why? Why semiconductor is so widely used? It is very important element in the manufacturing of computer chips. Okay, iPhone, phones, and all the touchscreen phones, all the chips. Okay, so that's the reason. One of the reason is because semiconductor 我们可以 control 它的 conductivity， 意思说在特别是如果你讲那种 devices 我们一定是要 high conductivity to be able to conduct current. So semiconductor is widely used is because we can control the conductivity of the semiconductor. Unlike metals, since metal is very good conductor, but we cannot control it. And also at high temperature, it is going to behave very differently. Metal, generally, they conduct very good. But if at high temperature, they do not conduct very good. Semi-metal, at high temperature, surprisingly, they are very good. At low temperature, at room temperature, they are not as good as metal. Non-metal, no need to say that one we don't use it. Okay, so that is why in the manufacturing of chips, computer chips, we use semiconductor because always your device will be heat up, right? Every devices will have a lot of heat. So we don't want the heat to affect the conductivity. That's why we use semiconductor. And later, when we go into the lesson, you will know more detail, okay, about it. Now let's understand a few things, okay? But first, 记得我讲这个 orbit 不代表它的 electron path 对吗？它代表什么？这种 shell 它是代表 energy level. Okay, the higher the orbit, the higher the energy level, meaning the energy electron at the outermost will have the highest energy level compared to the electron at the first shell. Semiconductor is any element that has 4 valence electrons, and all these 4 electrons they have the same energy. This atom has the same energy as this atom, sorry, this electron, okay, has the same energy as this electron, has the same energy as this and this, because they are all on the shell, on the same shell. Okay, what happened when I combine the silicon atom with another silicon atom? This is only one atom, right? If I combine with another one, there's a bonding, right? If I combine with 4 silicon atom, because one silicon atom got 4 valence electron, I combine with 4 silicon atoms, up, down, left, right, then I get octet arrangement. That is the stable arrangement. Okay, so each silicon will share one atom and then to form a stable octet. So here, this silicon atom will share one and this will share another one to it. Up here, this silicon will share one and this one will share with it. Same with here, here. All this electron, what are they doing? What are the valence electron doing? They are orbiting. They are moving from one atom to the next atom and then come back, and to the other atom, come back. So they are doing a job. What is their job? Their job is to be in the valence pairing, okay? To achieve octet arrangement stable, they have to pair with one another, right? So they are doing this valence job. We call it the valence duty, okay? So they have a job, they have one job to do the valence duty. And, okay, now, electron at the valence shell, they have a certain energy level. The energy level is only suitable for them to do the job. They cannot escape, okay? They cannot escape, they cannot jump out, they are stuck. They are stuck to do the job of a valence. Go here, go there, okay? Now, when I combine one atom with other atom, a lot of silicon atom, what do I get? 如果我 combine 很多个 atom 一起，只是单单 silicon atom 罢了，没有其他的 atom 我就拿到 silicon crystal, like a lattice. You can see from the diagram here. Okay, now here we have the silicon lattice. Each silicon represent one atom, and you can see the four-side pairing with another atom. So this one, they form a very stable arrangement. When they pair, right, what happens to the energy level of the electron? Electron 每一粒 electron 在 atom 里面它有它自己的 energy level, okay? 而且它是 based on shell 如果好像在第4个 shell 的全部那种 electron 是有同样的 energy level， 可是当你 mix 它们在一起的时候，是你 form 一个 crystal 的时候，它的 energy level 会再 readjust， 它好像会有一个redistribution of energy, okay? Redistribution of energy. So now the energy level of every single electron will change, okay? Now, each electron has energy level, right? So if I have 1 million electrons, then I have 1 million different energy level, okay? And this energy, how do we represent it? We represent all this energy in the band, the band theory. Okay, this is increasing in energy. Going up means increasing in energy. Let's say there are 1 million electrons here. Okay, the first electron having this much energy. I draw one line. The second electron has this much energy. Third one has this much. Okay, if I plot every single energy of every single electron, I will get 1 million line. Okay, 1 million lines, and these are we call the energy level. Okay, energy level. Each line represents a specific amount of energy the electron has. So if you plot everything together, we will get two groups. One is the higher energy group. Another one is the lower energy group. Okay, some electron, they will have higher energy. Some electron, they will have lower energy. That is random. Okay, the lower energy electrons, they will be at here. Okay, if I label the electron, okay, somewhere here, this is the electron at this specific energy. This is another electron. This is another electron. This is another electron. Majority of the electron will be at the lower band. Here you have many energy level, a collection of energy level, we call it band. That's why you hear in your chemistry, you learn about energy band, right? The higher band, lower band, all this. It is a combination of every single energy level. So majority of the electron will be at the lower band and minority of the electron will be at the higher band. What do we call this band? This higher band, we call it the conduction. The conduction band. And this band is, we call it the valence band. Okay? Electron 在 valence band 里面的，它们的 energy 不够 electron 在 conduction band 的高。所以如果它们的 energy 不够高呢，这样它们就永远 stuck 在那边 ，stuck 在那边做什么？做它的 pairing。Their only job is to do the pairing. They cannot escape. What happened to the electron at the conduction band? Those that have higher energy level, those that are fortunate enough to have high energy level. This electron, right, they can move around in the crystal structure. This is the crystal structure. So this is one single atom, right? If I take one Si, this is the atom. Electron at the valence band here, it is inside this atom. Okay, inside this atom. All these electrons in the valence band, they are inside the atom. The electron at the conduction band, they are higher ranking one. They can move out. They can jump out and now they stay in the lattice structure. This is the lattice structure. They are not in one single atom. 他们不是在 atom 里面，他们已经是跳出来了。可是它跳去，它不是完全离开那个 metal 啊，它是还在那个 metal 里面，它只是在那个 metal 的那个 lattice structure 那边。前一个 lesson 我们讲到 thermionic emission， 记得吗？我们烧它，然后它会 emit electron。那个不同，那个 electron 它是完完全全离开那个 metal。That is like the electron is escaping, is never coming back. This is different. This electron is escaping the atom only and is still staying at the lattice structure. What do we call this electron? This electron, we give it a name as you are already familiar. This is called the free electrons. Okay, so who is free? All these three, they are free. Those that are at the conduction band are higher energy level. This is free, this is free, this is free. So we have three out here. 1, 2, 3. These are all stuck. Okay. So how do we make the electron go from the valence band to the conduction band? Okay, you see, just now I said when you mix all the silicon atom together, you get a crystal and there's a redistribution of energy, right? There's a rearrangement. Some will be higher, some will be lower. And how do I increase the electron and I want to make it free? I want to increase the number of electron in the conduction band. Okay, this is the atom. Pair with another one. This is another one. Another one. Okay. If I hit this structure, I can give it energy by hitting it. Okay. So I hit it and the electron vibrate vigorously, and some electron they get enough energy, they can jump out. They can escape from this duty. This electron, they jump out and they become free, like the one in the lattice here. They are not bonded by any atom. This electron here, it can leave its valence job. Okay, the rest of the electron continue to do the job. This one can leave and then it becomes free. Okay, what is it doing? Nothing. This electron is doing nothing. Okay, it's doing nothing and it just move around. And it move around at a very high speed. At a very, very high speed. Okay, so it move around in pattern like this, zigzag, go here, go here, go here, like wandering around, nothing to do. Okay, so these are the free electrons. The valence electron is continuing doing the pairing. Okay, so if I hit it, then I can make more electron jump from the valence band, go up to the conduction band. Here, I hit it continuously. I can make it jump up. I can make this one jump up. I can make this one jump up. As a result, I get what? I get more and more electron in the conduction band. Okay, so meaning that when I hit the semiconductor, then you will see that more and more electron come out to the lattice here, 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 here. Okay, they pop out, become free. They have enough energy. Okay, now, are we hitting it? We are already hitting it. Okay, we are already hitting it because at room temperature, that is about 300 Kelvin. Okay, absolute zero is what? Absolute zero is 0 Kelvin. So we are already hitting it because at room temperature is 300 Kelvin. At 0 Kelvin, all the electrons would be at the valence. Imagine 如果是在 absolute zero 的时候啊，没有 electron 可以在 conduction band， 因为它们不够 energy。absolute zero 就是很冷，然后又没有 heat energy， 没有 energy， 所以全部 electron 会在 valence。所以如果你把它拿去单单去拿去 room temperature， 你已经是算是你在烧它了，因为 room temperature is 300 Kelvin from the absolute zero. So at room temperature, 它已经是有一些 electron 是在 conduction band 了的，可是不多。你要讲 increase， 你再继续 increase 那个 temperature， then 它会越来越多 electron 在 conduction band. Okay, now 原因是什么？为什么我们要降多 electron 在 conduction band？ OK， 当我 apply EMF 的时候 ，let's say 我 apply potential plus minus. There's a potential going in this direction across it. What happened to the electrons? The free electron here is attracted to the positive. Okay, so it will move, it will start to move. The moment I apply EMF voltage, this electron will start to move towards the positive because it is attracted by the positive. How about the electron that is doing the valence job? Here, inside here, another one here, another one here. All these electrons, do they move? Answer is no. They are not attracted by the positive plate. Why? Because they are closer to the atom. They are closer to the atom. The nucleus of the atom is also positive charge. So instead of being attracted by the plate, they will be attracted by the nucleus of the atom, which is positive charge. And that is stronger. It is pulling them, preventing them from leaving their shell. Okay, so when you apply EMF, only the free electron is moving. The valence will keep doing its usual job. Okay, not coming out. So the electron that you get, the flow of electron, we all know that current is the flow of charges. So if you have more free electron flowing, then you have higher conductivity. You have higher current. How do I make it more free electrons? I heat it so that more electrons jump to the band, conduction band, and they can conduct electricity. Okay, all these electrons, they can conduct electricity from the conduction band. The electron down here, they cannot conduct electricity. Okay, so that is why semiconductor, their conductivity can increase at high temperature. At high temperature, they are very unique, not like metal. Metal, at room temperature, metal is better than semicon. At high temperature, semicon will outperform metal. Okay, that is why in the manufacturing of computers, okay, we use semiconductor because they easily heat up. And when they heat up, we don't want conductivity to drop. We want conductivity to increase. Okay. Now, let me go to the next slide. Okay, here we look at the difference between metal, semi-metal, and non-metal. So the first one, you can see that this diagram is the energy level diagram. Okay, energy level. It is showing the energy of every single electron you can find in the substance. Okay, so if I plot all the energy levels, then we compare insulator, semiconductor, and conductor. Now, insulator, right? Insulator, this gap, here is the gap. This is the energy gap. It's very large. It is the largest among all this. Okay? If the gap is very large, then that means that you need to give it a lot of energy to make it jump to the conduction band, okay, to make it conduct electricity. So a lot of energy must be given that it is not enough. Still, you heat it for hours, still the energy is not enough because the gap is too large. Okay, so this gap, we call it forbidden gap, meaning that if the electron want to conduct electricity, they want to leave their job, they need to overcome this forbidden gap. And when you supply the energy, it has to be exactly the amount. For example, here, if the electron have an energy of 3 electron volt, EV is the electron volt, means the energy of the electron. And up here needs 10 electron volt. 如果你要 send 那个 electron 去上面，你要准准 supply 它 exact amount of energy, 10 electron volt, only that it can jump. 如果你 supply 它很像 let's say 7, okay, halfway, then it cannot jump because no electron can exist in this gap. Okay, they found that all the scientists, they do all these experiments, they found that no electron, not even one, can exist in between the two gaps, in this gap. That's why they call it the forbidden gap. Okay, so you need to supply exact amount of energy to push it up. 就好像你可以把它想象成好像你上楼梯这样子。如果你要上第3个 step， OK， 你一定要开到第3个 step。OK， 如果你到第2个半你就跌倒。OK， 如果你到第2个半你跌倒，然后你就 stuck 回在原本的地方。所以如果你要上第3个 step， 你一定要踩到第3个 step。你要上第5个 step， 你一定要踩到第5个 step。你踩到一半你就上不到。OK， it's the same analogy. So same with this one. You have to apply the same exact amount of energy to send it up. Okay, now insulator 它的 gap 太大，你继续烧它，给它 energy， 它都不够，反而那个 metal 那个 non-metal 自己都溶掉了。The metal melt first before the electron can gain enough energy. So insulator is no hope. It cannot conduct electricity. This one out. Okay, no matter how much energy, it cannot. All right, let's go to the second one. Semiconductor, we just talked about this. Semiconductor, 它的 gap 比较小一点，所以如果你 hit 它， then 它的全部的 electron 可以跳上去， it jump up and it can conduct electricity. So you get more free electrons at high temperature. Okay, and initially, before you even heat it, right? Before you even heat it, some electron is already up there. Some electron is already up there because remember I said at room temperature, you are still heating it already at room temperature. So some electron will be above. Insulator, no, all at the valence. Okay, so when you hit it, then more and more will be above. Then we go to conductor or metal. This is metal. Okay, this is semi-metal. Metal 它很特别，就是它的 conduction band 跟它的 valence band 是 overlap 的。这个代表什么意思？意思是说是 let's say 如果画一个 electron 在这边，这个 electron 是在那个 overlap 的 region 呢，它可以是在 conduction band， 它可以是在 valence band。如果你要它 conduct electricity， 它可以 conduct， 因为它有足够的 energy。如果你要它 stay 在 valence 那边做 pairing 的 job， 它也是可以。That's why it is in the overlap region. So here, it looks like this. This is the atom. This is another atom. This electron, it is doing the pairing. It goes here round and round, and then suddenly you supply EMF. It can jump out. It can do the conduction. If you do not supply EMF, then it can come back and it can continue to go round and round and round like this. This is what happened in metal. So it is special a bit. The electron can do two things. They can multitask. Okay, so meaning that without hitting it, all these electrons, they can already conduct electricity. I don't need to hit it. That is why metal, okay, naturally, they are very good conductors. They are very good conductors. Now, maybe you ask, why when I hit metal, the conductivity will drop? 为什么我烧 metal 它的 conductivity 会减少呢？不是应该增加吗？因为越来越多上去嘛，对不对？ Okay, there is another reason actually. There's another reason because when you hit the metal, the resistance will increase. Okay, because the atom they vibrate more, right? Resistance 是什么？ Current 是 electron flow. Resistance 是谁在 block 那个 electron flow? The vibrating atom, they are blocking the electron flow. You have here many atoms. The electron want to go from left to right. They have to go through these obstacles. What are these obstacles? These are the atoms. Remember, what is this electron? They are the free electrons, meaning that they are outside of the atom. They are not inside the atom. The valence is the one inside. This is the free electrons outside. When they flow, they will run into many atoms. Okay, so when temperature is higher, this atom, they vibrate very aggressively. They go here in every direction. It is going to add resistance to the electron flow. That is how resistance comes from. Okay, so when temperature increases, resistance will increase. And that is why the conductor, metal, at high temperature, they do not conduct that well. Okay, they do not conduct that well. Okay, 它的 electron 会上去吗？会啊，会上去啊。只是它的 resistance 增加的那个 weightage 大过它的那个 free electrons 上去的那个 weightage. Okay, the increase in resistance has a higher weightage than the increase in the free electrons in metal. Okay, so the bottom line is what? The bottom line is semiconductor at high temperature, what happened? Conductivity will increase. This is one very unique characteristic of semiconductors. Okay, so now 我们去下一个slide. OK， 来，intrinsic semiconductor。OK，intrinsic 的意思是什么？intrinsic 的意思就是pure。intrinsic means element at its purest. Okay, what is a pure element? Let's say ore. Do you know what is ore? Like a rock obtained from the earth crust. Okay, it's naturally occurring. Ore is like basically it's like a rock, and then the rock has a lot of mineral. Okay, minerals 就是像那种 element, compound, and naturally occurring. Those elements that you see in your periodic table, those are minerals. Okay, so it looks like a rock with a lot of minerals, and certain rock has higher percentage of certain minerals. For example, some rocks, they have high percentage of silicon. They have other element as well, but high percentage is silicon. And there are some other rocks, they have high percentage of calcium, let's say. Okay, so that's what is limestone. Okay, you are familiar with limestone. So limestone is they have high percentage of calcium. Limestone is an ore. Okay, so these rocks you can think of it like like chips mall. Okay, 有吃过 chips mall 啊，全部人。Okay, chips mall 那个the cookies the chocolate cookies, they have a lot of chocolate chips and nut on top, right? So the whole thing, the cookie is the ore. And if I only want the chocolate chip, then I only pick up the chocolate chip. I won't pick up the nut. I won't pick up the cookie. I only take the chocolate chip. So I'm extracting the chocolate chip so that I'll only have chocolate chip. And then I throw the cookie. Okay. So same with the ore. We have an ore, the rock. We have silicon. We have oxygen. We have carbon, any element. But I don't want them. I only want the silicon. I take only the silicon. I take only the chocolate chip. And then I extract it. Then I get intrinsic semiconductor. Intrinsic semi-metal, which is silicon. Because I extract only the silicon, so the substance I have now has only the atom of the silicon. There's no other atom, no oxygen, no other atom, not even a single one. So it's every atom is silicon. That is the purest element. Okay, so that is the meaning of intrinsic semiconductor. Okay, so 你可以看我的 diagram 这边 the crystal. So this shows the silicon crystal and intrinsic semiconductor. Every atom is silicon. Now, intrinsic semiconductor, the energy level. Okay, like I said just now, some electrons, they are at the conduction band, right? And majority of them, they are at the valence band at room temperature. At zero, absolute zero, everybody at the valence. Nobody is at the conduction. So at room temperature, some of them are at the conduction band. Okay, now here, when I hit it, what happened? Some will jump, right? Some will jump. What happened when the electron jump? Here, we got a pairing. This one with this one. The octet. Okay, 1, 2, 1, 2. Okay, let's say I hit it. This electron here, I hit it, and the electron jump out to the lattice. become a free electron. When they jump out, they are going to leave a vacant seat over here. We call this vacant seat a hole. Okay, a hole is like a seat that is vacant because the electron already escaped. So it is leaving a vacancy, we said vacancy. OK， 你可以把它想象这样子。Imagine 在一个戏院里面in a cinema, you have the VIP seat and the normal seat. The VIP seat is on top, second floor, the balcony seat. Okay, and the normal seat is at the ground. Okay, in a cinema. Let's say there are 100 seats at the bottom, and there are also 100 seats at the top. And imagine that we have 100 people coming in. All 100 people, they are sitting the ground floor. So meaning that every seat is taken, right? Because you have 100 seats and you have 100 people. So full seat at the bottom. Nobody is sitting on top. Okay, that is at absolute temperature, absolute zero. All the electron is at the valence band. Okay, now at room temperature, some of them sit upstairs because some electron, they are at the conduction band, right? So some people will leave their seat and they sit at the second floor, at the balcony seat. Now, if I continue to heat the semiconductor, this electron, they escape. More and more electron go up and more leaving the seat at the bottom. So you have more and more empty seat, right? The empty seat, think of the empty seat as the hole. Okay, so the hole is the empty seat. The number of hole created is the same as the number of electron leaving. 3 people leave the seat, go up, you have 3 empty seats at the bottom. 5 people leave the seat, sit upstairs, you have 5 empty seats. So the number of free electrons you get is the same as the number of holes you get, right? So 5 people go up, that's 5 free electrons. 5 empty seats, that's 5 holes. So the number of holes and the number of electrons, they are always the same. Remember this. Okay, so we can write what? We can write Ne equals to NH. Number of electron 等于 number of hole. Okay, now 如果你 create hole 的话 what does the hole do here? The hole, right, they will attract electron. Which electron do they attract? They are not attracting the free electrons. Okay, they are attracting nearby electrons. They are attracting the electron that are at the valence band. All these electrons at the conduction band, okay, some of them, yes, they will be attracted, but majority of them will not be attracted. So the hole, they have a power. They have a power to pull electron and pull the electron come back because they are like a vacancy seat. You can think of it like the golf. Think of like the golf ball is falling into the hole. Okay, so the hole captures the golf ball. Any golf ball passes by, it will fall into it. Okay, so meaning that the hole is attracting electron from the valence, those that are doing the valence duty. Here. Since hole can attract, then anything that attract electron or negative charge, we call it a positive charge. That's why hole is a positive charge. We call it a positive charge carrier. Is it a proton? No, it's not proton. It is just a charge carrier. It is the absence of electron. It's not proton, not the same as proton. Okay, so it is positive charge carrier. So any electron passes by, it will fall into the hole because the hole is attracting. Okay, so here, the more free electrons you get, the more holes you get, because the number of electrons the same as the number of the hole. Okay, now what happens if I apply electric field? When I apply electric field, plus, minus. Okay, you see. First, there are two groups of electrons. First group is the conduction band, those free electrons. Second group of electron, they are the valence band, those that are doing the job. The free electrons, when I apply EMF, they will be attracted. So all these electrons, they flow towards the positive plate. These are the free electrons at the conduction band. And since they are flowing to the left, where is the current? Current 是 opposite electron flow 的 direction. 所以如果你的 electron 全部 electron flow 去左边，这样你的 current produce 就去右边。Okay, all these electrons, they are attracted, so we have a current produced in here. This is I current due to electrons, E. Okay, in this direction to the right. Now, I applied the same EMF. What happened to the electron at the valence band? Okay, you see. Let me erase this. Okay. This is the positive plate. Here's the negative. Here I draw the electron. Let's say we have like this. Okay, so this is the electrons. All these are what electrons? Are they the free electrons? No, they are the valence inside the atom. Okay, all this. So what happens is when you apply the EMF, this positive plate, it will pull the electron out. Okay, it will pull the electron out from the valence. And then it will make the electron leave the seat. So by doing that, once it pulls the electron out, then it will be a hole here. There will be a hole here, and here is still the electron, or the electron is still here. Okay, a hole is created because the electron come out, and then the electron enters the positive plate. Okay, and then it's neutralized there. Okay, it flows there. So leaving a vacant seat, this is the hole. Now, a hole has a positive charge, right? So meaning that a hole can pull electron. So this hole having a positive charge, together with the metal plate, they will pull the next electron just beside them. This one, they'll pull it here. They are able to pull the electron is because the electron is just next to them. These electrons, they are electrons in the atom. So the atom, they are very close, so they can pull them easily. Okay, they are not pulling the free electrons. They are pulling the electrons at another atom. Okay, so those electrons come here and they fill the hole. Once this electron jump out and fill this hole, then we have this become neutralized, become neutral, because you have one electron entered already, and this is hole. This is the like this. Okay, now same thing. This is positive. This is neutral charge. Because the hole, the electron already jump in, then it will become neutral. The hole is now here. It has a positive charge. It will pull another electron just beside it, and the electron jump out and come in. So you have this become the hole, this become the electron, this. Okay, every single time the electron jump here, so we have here, 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 this become the hole, and this become the hole, this become the hole. Okay, observe the movement of the hole. But where is it moving? It is moving to the right. Okay, each time the electron jump, the hole is moving to the right. The second electron jump is moving like this. Okay, actually, electron is the one that is moving. But we can also say the hole is moving because the electron jump out and fill. Then I also can say that the hole is going there. Okay, so the hole is moving to the right. Hole has a positive charge, correct? Has a positive charge. So this positive charge is moving to the right, means that there is a current, because whenever there's flow of charge, there's current. What is the direction of the current? The direction of the current is the same direction as the positive charge. So if the hole is moving to the right, then the current is also to the right. I. And this current is due to what? It is due to the hole, IH. We have another current here. This current is due to what? This current is due to the free electron. That is different. Okay, that is what is happening at the conduction band. We are talking about the valence band. Okay, so current is produced due to the movement of the hole. So we have total current is equals to IH plus IE. Okay, IH plus IE. This is what happens when I apply a potential difference across it. Okay, it will start to attract electron, and then it will create a hole. Then this hole will travel. Okay, this hole will travel. They conduct electricity. At the same time, the electron at the lattice will also move, and they also conduct electricity. Okay, so you can see my diagram here. All these free electrons is moving, and at the same time, the electron from one atom is jumping to another atom. Okay, then it's jump to another atom, jump to another atom, like this. From here, jump here, jump here. Okay, what is happening here is between the atom. One atom to the next, one atom to the next. So the hole is traveling in the atom. Okay? So you get current produced. That is the semiconductors. Okay, now We are going to stop a while. We have 5-minute break. Okay, 3 to 5 minute break, and then we come back at 8:03. Okay, so everybody take a break, and then I'll see you back in 8:03. We'll continue from there. 给大家，我们继续啊。Okay, so intrinsic semiconductor 就是单单silicon 罢了啦。然后intrinsic semiconductor 它有一个不好，就是如果它是 pure intrinsic 的话好像这一个它不能用来做devices，就很像比如说很像 gold 这样子的，很像 gold 了，gold gold cannot be made into jewels, ornaments, okay, because pure gold is so soft. So they have to add certain impurities into gold, and only they can make the jewels, the ornaments, okay, the decorative stuff. Okay, so by itself, they cannot make ornaments because gold is very soft. So the same principle to intrinsic semiconductor. Intrinsic semiconductor, the pure one, it cannot be made into devices. So you have to mix something. You have to mix with some impurities to improve the quality or the characteristics of the semiconductor. Okay, that is why we have two types. Okay, two types of semiconductors. First one, when we add impurities, I add very specific element that I call the trivalent. Okay, trivalent element. You see the word tri, what does that mean? Meaning the element that has 3 valence electrons in their valence shell. Okay, so when I add these two trivalent elements like indium, boron, and aluminium, then it makes a p-type semiconductor. Okay, now let me explain. You see, initially the silicon atom share with 4, right? 1, 2, 3, 4, 4 silicon atom. Si, 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 Si. If I remove this atom, I add impurities, meaning that I add any one of this, aluminium, I add aluminium. So this become aluminium, and aluminium has only 3 valence electron, meaning that it can only give 3 silicon atom. So what about the last silicon atom here? There is not enough electron that it can give, so it remains as a vacuum, a hole. Okay, this is the hole, and this is the electron from the silicon. The pairing is not done because we have absence of 1 electron. There is not absent, a deficient, okay, of electron here. All right, so when you mix 1 atom of impurity, like you mix 1 atom of aluminium, then you get 1 hole. Okay, if you mix 1 million aluminium atom, you get 1 million holes. Okay, so the number of holes that I get, I can control it based on how many atoms I want to add. Why is it called p-type semiconductor? They are called p-type is because hole is a positive charge. Okay, what happens if I add more and more aluminium atom is that I will have many holes. So the majority of the charge carrier is the hole. Okay, meaning that the hole will be more than the electrons, than the negative charge. That's why we call it the p-type. P means positive, okay, because hole has a positive charge, So you can remember it this way, p-type semiconductor. Now, also it is very important. This one is that you need to what is the charge? What is the charge of the semiconductor? Overall, the charge is neutral. It is not positive. It's very easy to think that it is positive because it has many holes, right? So students, they tend to confuse. They say, okay, it has many holes, then it must be positive charge. No, okay? Remember, the positive charge is the atom. Okay? When there's a hole, it makes the atom positive charge. It makes the atom positive charge, not the crystal, not the metal. Okay? So meaning that the electron is outside to balance it. There are free electrons outside that balance the charges. You see, before you mix it, when it is intrinsic, silicon is neutral charge. When you mix with aluminum, aluminum also it is neutral. You mix them together, you still get neutral. Okay? You still get neutral, but we have more hole is because of the arrangement. Of what arrangement? The arrangement of the crystal structure. This arrangement form a hole, but doesn't mean that overall the charge is positive charge. Okay? So remember the net charge. I write it here. Net charge is neutral because the intrinsic semicon is neutral. The aluminum, that the impurity is the aluminum I add, is also neutral. So if I mix them together, also I get neutral. Just the arrangement create one positive charge carrier. Okay, the number of proton and the number of electron is still the same, so it's neutral. Okay, now so 如果单单看这个 aluminum atom 它是 pull electron， 因为它有一个 hole 在那边嘛，所以它是随时随刻它都会 attract electron， 所以这个 atom 我们叫它 acceptor。 This is we call acceptor atom. So p-type semiconductor 它们是 acceptor. They are the acceptor. And another thing that you need to take note is what is the majority charges, majority carrier. Majority carrier are the holes. Okay, minority carrier, because the hole become more, right? The more you add, the more holes, and it greater than the number of holes is greater than the number of electrons. So minority carrier is electrons. Electrons. Okay, this one they will always ask you, what is the majority, what is the minority? So this is the p-type. What is the process? The process of mixing the semiconductor with aluminum, with impurities. We call it doping. Okay? Doping is the process of mixing with impurities. What is the use then? Later we'll see. Okay, why we want to do this, we will see. So here, by doping, I have created a semiconductor that want to accept electron. Okay, the more I replace with aluminum, the more acceptor atom we have. Okay, so I have created a p-type semiconductor, meaning that they are ready to accept electron. Okay, now the second type is, okay, if you want to screenshot, I go to the next slide. The second type is N-type. When an intrinsic semiconductor is added with pentavalent. Pentavalent means that they have 5 valence electron. Okay, like phosphorus, arsenic. Okay, do you need to memorize this? Yes, you need to know because they will ask. Phosphorus, arsenic. The previous one is what? Aluminium. Okay, just memorize one. Then it makes an N-type semiconductor. Okay, so here we have phosphorus. It has 5 valence electron. One electron is paired, another one paired here, another one here, another one here. So we got one extra. That extra electron, they will come out here as free electron. Actually, they are not entirely free. They are not 100% free electrons. They have energy level that is just below the conduction band. This is the electron energy level. Just below. So close that if you hit a little bit, it goes to conduction. Okay? So initially, before you hit it, they are not entirely free. They are not in the conduction band. They are just below this. Okay, you hit it a bit, then they become conduction. Okay. Now, if I dope with another phosphorus atom, I have another phosphorus atom here. Then I have extra electron here. I drop another phosphorus atom. I have one more here. The more I dope, the more electrons free I have. Okay. So, what is the net charge of the crystal? The net charge is what? Neutral. Okay. I have created more free electrons here, doesn't mean that it becomes negative charge. Because the number of proton and the number of electron, they are the same in the crystal. Just that we have more free electron. Okay, we have more electron that are free from the atom. Doesn't mean we are adding electron in the metal. So the charge of the metal is still neutral. Okay, so net charge is neutral. That's the first one. And what is the majority carrier? Majority carrier is electron. What electron? Free electrons, not the valence. Minority. Minority carrier, they are the hole. Okay, remember before you dope it, there are holes. OK， 你还没有 dope 它之前，它本身已经是有 holes 了的。OK， 记得我刚刚讲，就是 number of electrons 是等于 number of hole。OK， 有多少 electron leave the seat, go up at the balcony seat. That is the same amount for the holes. 5 leave, 5 holes. So number of electron is the same as number of holes. Now, if you dope with phosphorus, then you have extra free electrons. These extra free electrons will fill up the hole. Okay, so initially it's like this, Ne equals to NH. 当你 dope 它的时候 doping, then 你会拿到 more electron. 然后 some electron 它会 fill the hole. Some will fill holes. So become what? It becomes that the number of electrons is bigger than the number of holes. Because some electron fill the hole, then the number of holes become less. So overall, we get more electron than hole. So the majority carrier is free electrons. The minority carrier is holes in a n-type. 因为 majority 是 electron， 然后 electron 是 negative charge， 所以我们叫它 n-type semiconductor. Okay, now n-type semiconductor， 它这个 atom 有 extra electron 给你，对吗？这个是我们叫它什么 donor. It is a donor atom because it has one extra electron to give away. This is another donor atom. This is another donor atom. So overall, n-type is a donor. They have many electrons ready to donate. Okay, I repeat. Recall back. P-type, the one before, they are ready to accept because they have many holes. N-type, they are ready to donate because they have many electrons. These two together, one is ready to accept, one is ready to donate. When you mix them together, what happens? This one will donate to this one will accept, like this. That becomes the diode, the semiconductor diode. Okay, so semiconductor diode, which we will go next after this, is a combination of p-type and n-type together. Okay, one is receiving, one is giving. We get a diode. Okay, diode is okay. Let me go to the next one. You can take a screenshot of this, then I go to the next one. OK， 来，我们看这边。左边 p-type， 右边 n-type。p-type 本身的 charge 是什么 ？neutral。OK，neutral， 可是它有很多 hole。n-type 它也是 neutral， 它有 extra， 它有很多 electron，free electrons。把它们两个 combine 一起，这个是 acceptor， 这个是 donor。So what happened? This one ready to accept, this one ready to donate. So the moment you combine them, okay, now by the way, this is semiconductor diode. Okay, this is the structure of a diode. Okay, now the moment you combine them, there is a junction between them. This is we call the junction. It's like a boundary separating them. Okay, so once you connect, 你还没有 supply voltage 啊，你什么都没有做，你只是 combine 它们罢了。Straight away 啊，它的 electron 会直接跳过去，因为它会 attract 它嘛，对不对？这个 attract 它，所以它会跳过去，这个 electron 会跳过去，这个 electron 跳 ，all these electron they will jump. Okay, what happened next? You see, when the electron jump here, initially the n-type is neutral. When one electron jump to the p-type, the n-type now has less negative charge. So it will become what? it will become positive charge. Okay, again, they start off with neutral. So when one electron jump to the other p-type semiconductor, then the overall charge become positive because now one electron is already gone. And the number of proton and electron does not equal anymore. So when this jump, then here it will create a positive. This jump, it will create a positive. This jump, it will create a positive, positive, positive. Similarly, on the other side, when this one electron come here, fill this gap, it has gained electron. So this become negative. Okay. This one also, it has become negative because the number of electron of the p-type now is increasing. Negative, negative, this is negative, this is negative, this is negative. Okay, so the electron, they are jumping, they are hopping from here to here. Okay, what happened next? After the first row of electron, the first row of electron jump, then you'll get something like this. All plus, and the left side all negative. Okay, and this is not only happen at the layer closest to the PN junction. Okay, it's not just one layer. There are millions of layers. Okay, so every other layer will do the same thing. After the first layer jump, then the second layer will jump. This one, they'll jump here, all the way here. They'll jump all the way here. This one, maybe they have to make a little bit more effort because they are further. This one jump here. So it happened layer by layer. And then over time, you get something like a buildup of layer in between that we call the depletion layer. Okay, so this one, they build up. All these are, they have already jumped. When one electron jump into one hole, this process we call the recombination. Okay, recombination is when one electron jump into a hole. Okay, so after they recombine, it is going to form a layer. We call it a depletion layer. Okay, depletion layer. The depletion layer is formed at the junction. Okay, now they are not the same. 不同的 depletion layer 跟 PN junction 不同的 PN junction 是这个中间这个线，那个 boundary 它是一条线罢了。Depletion layer 是那个当你的 electron jump 过去的时候，它会 build up 一个 layer， build up a layer of charges, negative and positive. That is the depletion layer. OK， 然后这种全部你一 join 它就发生了，你不用 supply 什么电的 ，OK， 它就这样子 jump， 然后接下来到一个程度啊，它会 stop，OK， it will stop jumping until a certain point. Why it stop jumping? You see, when the layer become so large, that is the depletion layer. Okay, when it becomes so large, and when the left side become more negative, you can see here we have one row of negative, another row of negative. So in reality, there are many rows. So the negative charges build up here. They will build up, they will accumulate. 然后到一个程度哦，它 negative 哦，它会 build up 那个 charge 哦，它会变成 negative charge 哦，然后对面的 electrons 跳不过来，因为当它要跳过来的时候，它给这个 negative charge repel 走，它跳不过来。OK， so 一来它可以跳，因为它没有 depletion layer。当你有 depletion layer 了，这种 electron 就 stuck 在这边 ，they cannot jump already。Okay, so what happened then if they cannot jump? Then nothing happened. It just stay like this. It just stay like this, and we can say that there is a buildup of charge, right? So there will be a potential or voltage at the depletion layer. So the depletion layer has a voltage, and this voltage is preventing the electron from jumping to the hole. Okay, can it go reverse? After they jump, can they go back? Cannot already. Okay, it's like fixed like this. Okay, so when you mix them, they recombine and then you get this. So every semiconductor diode, they have a depletion layer. This is the reason. And the depletion layer has a voltage. Okay, what is the point of all this? Now, here, if I connect with a circuit, here I connect positive, here I connect negative. This, okay? This is positive, this is negative. This is p-type, right? Positive, this is negative. Okay, now, when I connect positive charge here, this one become positive charge. Because it's at the positive plate, here become positive charge. This positive charge, what happened? It will try to pull the electron again to make the electron cross the PN junction. Cross the depletion layer. And this negative charge, here is also negative. Negative charge repel negative. So it will repel the electron, it will push the electron to the other side also. So it's like helping, it's helping this. Both of this terminal is trying to pull the electron to the other side. But can they do it? Are they able to pull the electron to the other side? That depends on how strong is the depletion layer. Okay, so the voltage you supply, if it's not greater than the depletion layer voltage, then they cannot pull the electron. I repeat, depletion layer, okay, what is the voltage of depletion layer? Normally it's like around 0.6 volt or 0.3, 0.6, depending on the type. Okay, so the layer, the voltage build up here is 0.6. If you supply 0.5 volt, can they move the electron across? Cannot. It's not enough because the depletion layer is stronger. If I give it a voltage of 3 volt, then it has enough power to push the electron across. And then what happened? The electron will repeat the same process. They will fall into the hole and then the recombination process again. So as a result, this thing, the electron can pass through. Electron can pass through. And when the electron jump to the other side, they will enter this circuit and then the electron will continue to flow here, here, and here. So as a result, you get a net flow of charge around the circuit and there will be current flow. Okay. Now, so this connection, there will be a current flow if your voltage is higher than the voltage of the depletion layer, right? So the depletion layer voltage 0.6, we give it a name. That is, we call the junction voltage. Junction voltage 就是这样子的意思 ，OK？ 它是那个 depletion layer 的 voltage， 所以你 supply 的 voltage 一定要大过 junction voltage， 你才可以有 current flow。如果小过，没有 electron 可以 jump 过去。这个 connection 你可以看到我的 positive plate 呢是 connect 去 P type， 我的 negative plate 是 connect 去 N type。所以 positive 去 P， negative 去 N， 那个我们叫 forward bias。 It is a forward bias connection. Please remember this because this is very important. Forward bias means that the positive is connected to the P, negative is connected to the N type. Okay, what is the symbol of the diode? Looks like this. Okay, the diode symbol looks like a triangle, and then like this. Okay, you can see in your book. This is the symbol. You see the arrow at the body of the diode. The arrow, which is the body, is pointing to the right. That means that it is P here, it is N here. We always go like PN. Wherever it's pointing, we go PN. Okay, if it's pointing here, then this PN. Okay, P type and N type. Okay, so this one, I can draw it like this. This one, the connection is like this, right? The first one. P on the left, N on the right. Okay, this symbol means this whole thing. This whole thing you see is this symbol here. PN. And then here I connect to what? Positive. Here I connect to negative. 一定是要 P join 去加 and join 去减，我们才可以叫 forward bias。如果这个加 join 去 P， 然后这个减又 join 去另这个有一个 P， 有时它有可能是 PP 或者 NN， 这样子也是不算 ，OK 不算，一定要加 join 去 P， 减 join 去 N， 我们才叫 forward bias。forward bias 你也是可以看那个它的身体，它是指向右边哦，然后你看那个 current flow，current flow 是 clockwise。所以 current flow 的 direction 是跟着它的身体的 direction 是一样的，两个都是指去右边，这个也是我们叫 forward bias， 你也是可以这样子来看。Okay, forward bias. So forward bias connection is like this. In forward bias connection, is there any current flow? Yes, only when the voltage is higher than the junction voltage. 所以如果你 plot graph 哦，你会看到它的 graph 是这样子。这个是 voltage， 这个是 current IV graph。它的 graph 是这边是 junction voltage 0.6，你 supply 的 voltage 如果是低过0.6啊，你的 graph 是会是这样子，小小。OK， 你可以看 the curve is like this. After the origin, it is very flat. All this is before 0.6 volt. The current is very, very small. When your battery supply reaches more than 0.6 volt, the junction voltage, then it will increase like this. Dramatically, it increase like exponent. There's a huge increase in the current. Okay, that is only when it is above the junction voltage. This graph you need to know also. It is the forward bias graph. If the connection is in forward bias. 可以吗？ Okay. Now, 如果我调转这个呢？如果我调转这个，给我擦掉这个先。现在我 flip 我的 terminal 啊， 这个是减，这个是加，这个怎样画 ？OK，diode P 在左边 ，N 在右边，所以它指去右边。然后我的 terminal 是减加 Pn。OK，看那个 current flow，current flow 是 anti clockwise，跟这个 diode 的 direction 相反，所以这个是什么？这个是 opposite of forward bias，we call it the reverse bias。Okay， reverse bias。What happened in reverse bias？这个是 negative，这里也是 negative，positive，这里是 positive。这个 negative 会 repel electron，所以 electron 根本没有可能可以 jump 过来，因为不只是那个 depletion layer repel 它，这个 plate 的 negative charge 也是 repel 它，所以 electron 跳不过来。不只是它跳不过来哦，加上这里是 negative 哦，它会 supply electron 进来这个 hole，supply 进来这个 hole，进来这个 hole，进来这个 hole，所以它会弄到这个边 negative。谁 supply 的？从那个 battery 来的 ，OK， 不是这边的，不是这边的 electron 呢，是左边这边的，它 supply 进去，然后有 recombination，then this become negative。Okay, at the same time, on the right，这个 positive terminal 它会 pull 这个 electron 过来，pull 这个 electron 过来，pull 它过来，全部它会 pull，所以它会弄到这个也是 positive。As a result, the depletion layer, what happened? The depletion layer widens. It becomes wider and wider, and it makes it almost impossible that the current can flow again. So current will not flow because the charges, there is no exchange of charges at the middle. Current 只可以 flow 当 electron flow 一个 closed loop，或者 positive charge flow 一个 closed loop。这里它没有 form closed loop，因为中间没有的 exchange，所以这个是 no current flow。That's why reverse bias no current will flow, no current, and also the depletion layer what happens? Widens. Okay, depletion layer widens. So this is reverse bias. The connection you need to be able to tell. They will give you the circuit. They tell you, is this forward bias or is this reverse bias? So you can see from the current. Okay, so overall, we got two types of connection, reverse bias and forward bias. Forward bias is when if you go above the junction voltage, very large current you will get flowing in the circuit. For reverse bias, if you, let me go back first. Sorry, this one. For forward bias, very large current will flow. If above junction voltage, reverse bias, no current will flow. Okay, no current will flow. So Meaning that, what is the function of diode? The main function of diode is to control the current flow by allowing the current to flow in only one direction. Because you see, forward bias, current can flow, but reverse bias, current cannot flow. So if I switch this battery to an alternating power supply, AC 做什么的 ？AC 是它会换 direction 对吗？一来它先 flow clockwise，过后它就 flow anti-clockwise like this. Okay, so when the AC flow clockwise, that is a forward bias. So current can flow through. When the AC flow change direction, that become a reverse bias. Can current flow through? Cannot. So what happened if no current can flow through? Then no current, the whole circuit no current. Okay, so you see AC, how does the graph look like AC? AC 的 graph 是这样子对吗？ Sine graph. 一来是 positive value voltage， 然后 negative value voltage。negative 就是它转方向嘛，所以只是 clockwise 的可以 flow，anti-clockwise 不可以 flow。所以你的 graph 看成是这样，你的这个全部 negative 的 graph 没有掉了咯，因为这边 current 不能 flow 嘛。So you don't have the negative region. Okay, let's take the clockwise as positive lah. So whenever the current change direction, there's no current flowing in the circuit. And when it change back, then current come back again. So you get graph something like this. You get graph looks like this. Up, decrease. And when it go bottom, there's no current. So I don't draw it like this. Up, decrease. No current. Up, decrease. No current. This is the graph you get when you put a diode in the circuit. Okay, this is how do you get this graph? You measure, you get this graph with using the CRO. Okay, if you have a resistor here, and then you connect this to CRO, meaning that you are measuring the current across the resistor. And the resistor is in this circuit, right? So it will look like this. If you connect this resistor to CRO, then you'll get something like this. Okay, the bottom part is missing because the diode doesn't allow the current to flow in that direction. So here, what we have done, we have changed AC current to DC current. This is DC current because current flow in one direction. Okay, one direction. But there's a disadvantage because suddenly you get current and then no current. Suddenly you get current and then no current. You get current and no current. This is the only disadvantage. So it's like sudden peak and then drop, peak, drop. But we have a method to solve this, and this will be discussed in the next lesson because we don't have enough time. Okay, so here, this circuit, we can call it a rectifier. This is a rectifier circuit because we have changed AC to DC. So the waveform here, it is rectified. Okay, so rectification means that I change AC to DC. Okay, from an AC circuit, I change to DC circuit. That is the process. The process is called rectification. And rectification is done by using diodes. Okay, and together with the connection. Okay. Now, all right, I think we'll stop here. I think it's too much for today. Yeah, we'll stop here. All right. The rest about the rectification, I will cover it in the next lesson. Okay. So today we went through the semicon, we went through the types and also the diodes, forward bias, reverse bias. Okay, and a little bit of the rectification. Now, if you're experiencing lagging, don't worry. Later, I'll post the video in the group. Okay, and also the previous video last week I will post it also after I finish uploading. Okay, so yeah, we still have a bit of time, so you can take a rest lah. Take a rest, and then I will send you the homework for today on the semiconductor. Okay, 那个 homework 啊，我 send 你的那个 homework，它有包括 rectification 的，你先 skip 那一个先。OK， 你看到那种 rectification 的 circuit， 好像那种 bridge 啊 ，something like this， or the bridge。Okay, those you can skip first. You do the one that we just discussed. Okay, because I haven't covered fully the rectification. But if you know how to do, then you can do. Okay.